Algebra 2, Quadratic Functions exam. This is Module 3 on quadratic functions, mostly in vertex form. And we're going to go over these 14 problems. This one, number 1, has 5 separate subparts to it, A through E. Choose the true or false for each statement about the function fx equals negative quantity x plus 4 squared minus 6. And we're asked different things about this function. I think a very helpful thing to do would be to sketch a graph of this function, which I'll do right here. There it is. Get the right pen. Okay, so the first thing I would do is graph this function that's in the form, remember, f of x is equal to a times quantity x minus h squared plus k, and in this case h is going to be equal to negative 4, and k is going to be equal to negative 6. So that means that we're going to have an axis symmetry at x equals negative 4. So x is equal to negative 4, and k is equal to negative 6. So we go to negative 6 here on the y-axis. So there it is. And a being less than 0, we're going to have a downward opening parabola, something like this. So this is just a general sketch to be able to answer these problems quite easily, I hope. The axis symmetry is x equals negative 4. That is a true statement. The maximum value is negative 6. Yes, it is. Because since the parabola is opening downward, this value of negative 6 is a maximum value to that function. The minimum value is negative 4. Well, that is not true. It's not possible with a quadratic function to have both a maximum and a minimum. So only one of these could possibly be true. D, the function is increasing on negative infinity to negative 4. And yes, we're talking about the x value of negative 4. So negative 4 is the last x value for which the function is increasing afterwards. After negative 4, to the right of negative 4, the function will start decreasing. And the last one, e, the function is increasing on negative 6 to infinity. Well, negative 6 is going to be over here. And so for this portion between x equals negative 6 and negative 4, the function will be increasing. Now if this thing says the function is decreasing on negative 4 to less than infinity, that would be a true statement. But because of this portion from negative 6 to negative 4, that makes this a false statement. Okay, next, problem 2. Identify the domain and range of the function fx equals quantity x minus 9 squared minus 7. The domain for this quadratic function and all quadratic functions is all real numbers, which could be articulated in interval notation like this, and inequality notation. You could write it like this: greater than negative infinity, less than infinity. And the range. Well, the range is one where we had more people that had trouble with this. And just to make a sketch of the graph of this function here, we have in this form here, h is equal to 9 and k is equal to -7. And so 9 over here, x equals 9, that's going to be our axis of symmetry, and then -7. Okay, -7 will be right here. So here's our vertex. And we have a is 1, so we're going to have an upward oriented parabola. So I just draw that little piece there. And our lowest value here is going to be -7, y equals -7. So our range is going to be starting at from a minimum of -7 to less than infinity. And then you could do this different ways. If you write this as inequality notation, you say y is greater than or equal to -7. So I saw people get things reversed for this range. Domain, people did pretty well with range. Took points off for saw reversing and so forth. That's what it really should look like. Okay, next, 3. Write the quadratic function in vertex form by completing the square. Well, to the right, I'm going to do this. We're going to write this as f of x equals, I open parentheses and put x squared minus 2x. Then I put plus and leave these little dots here for blanks. On the outside, I'm going to put minus, leave these other dots here, and -3. So what we're going to do is place inside these parentheses here a value, and that value is going to be determined by taking that middle term, in this case the coefficient of that, -2, and divide that by 2 and get -1. And I'm going to asterisk that -1. Then we're going to take that -1 and square it to get 1. So 1 is the value that goes right here. And then we have to put -1 on the outside of the parentheses to offset the 1 that we added inside the parentheses. And now what we have is f of x equals, remember I asterisked this -1 here? I did that because we're going to put here x minus 1 squared. On the outside we have -1 minus 3, which will be -4. So our answer is going to be, for this one in vertex form, f of x is equal to 20x minus 1 squared minus 4. And what I did prior to recording this video is I entered the original equation in standard form. And when we graph that equation, this is what that looks like. And then we can test our answer by going below here and entering that function that we got in vertex form. So I'm going to put x minus 1 squared minus 4. And if this is correct, we should see this red curve trace right over the blue curve. And we see it. And we can also go to the table view and see the same output values for each function. So that is a correct answer. Number 4, another completing the square problem. going to put f of x is equal to, open parentheses, x squared plus 6x plus dot dot dot, we don't know yet, minus on the outside, dot dot dot, and finally plus 7. Now determining what goes inside to complete the square, we take this coefficient of the middle term, 6, divide that by 2, get 3, and I'm going to asterisk again that 3, and continue to the right, we take this 3 squared and get 9, which is the number that is going to go right here. So plus 9, and then we have to subtract 9 on the outside to compensate for having added 9 inside the parentheses. And then we have, for this, our answer is going to be f of x equals, remember I asterisked that 3, we'll put x plus 3 quantity squared, and then on the outside we have minus 9 plus 7, and that condenses to minus 2, so that is going to be our answer, which will go right here. I'll just write it out here for quantity x plus 3 squared minus 2. And let's see, checking as I go along, make sure everything's worked out. Yeah, that's what it is. Okay, 5. Does each function have either a maximum or a minimum value of 3? So we have 3 options, yes or no, for each of these functions, and we could convert these into vertex form, and if we saw a k value of 3, we would know that that would be definitely a yes. But a more expedient way to do this, given the tool provided to you in hand, is this graphing calculator. So I'm going to enter these in the graphing calculator and see what we have. Okay, the first one we have is negative x squared minus 2x plus 2. So minus 2x plus 2. And here we have, and the way the graph is set up, we have these lines, and here at y equals 3, we have a maximum. So that means our answer to A here is yes. Okay, the next we're going to enter is x squared minus 6x plus 3. X squared minus 6x plus 3. Graph. No, we do not have, our vertex is going to be here at negative 6, y equals negative 6. So the answer to part B is no. And finally, for part C, we have x squared minus 8x plus 19. So x squared minus 8x plus 19, graph. Now in this one, the lavender one, we have a minimum value of negative 3. So that would be a yes. Okay, that's problem 5 worked out. Next, problem 6. A model rocket is launched upward at a speed of 98 feet per second from a platform 7 feet above ground. Choose true or false for each statement about the rocket's flight. And if you look at the answers here, we have A is the rocket will reach its maximum height after 3 seconds. B, the rocket will reach its maximum height after 6 seconds. So both of those cannot be true. And same thing for C and D. We have maximum height 151 feet, and D we have maximum height of 302 feet. Both of those cannot be true. What happens, the basic form of this equation is a projectile motion function in feet per second, which is negative 16 t squared, t being seconds, plus v sub 0 t plus h sub 0, and v sub 0 being the initial vertical velocity and h sub 0 the initial height. And so we're going to go ahead and make this function here h of t equals negative 16 t squared plus 96 t plus 7 for 7 feet. And we can now enter this in the calculator. So I'm going to clear everything out here. So I put negative 16 t squared plus 96t, using x of course, plus 7. And now we can analyze the graph. We're looking for the vertex. We're going to have a downward opening parabola. That vertex is going to give us the answers we need. When we press graph, we get this. Now, what I'm going to do is the answer choices give us a direction to where we can set our window, and I'll show you. We know that the greatest possible maximum height is 302 feet, and the greatest possible time is 6 seconds. So that can help us set our window. If we go to window, I'm going to set x minimum 0, and I'm going to put 7 seconds because that's the maximum. We're given 6 as a possible maximum there for time. And then for y maximum, I'm going to put 310 feet, and I'm going to go by tens. And so we'll be able to see here what's going on, I hope. Graph. Yeah, so we have, looks like 3 seconds. This maximum is going to be right here where I'm circling the vertex at the top, and not 310 feet. Looks like it's that halfway. So just visual inspection would give us our answers already, and our answers are after 3 seconds, not after 6 seconds, and 151 feet yes, and not 302 feet maximum height. Now we're going to drill down and look at the more precisely. The thing we can do is go to second, trace, and get a maximum. And we have a vertex blinking here, and we have the question left bound. We can arrow to the left of that vertex, press enter, and then it says right bound. So now we arrow back to the right of the vertex, and once we're there we can enter twice. we see this maximum of 2.9999988, which is going to be like 10 millionths off, and then maximum height of 151. Also, people will sometimes look at the table view, and you can see at 3 seconds we have a maximum height of 151. The table view is not as precisely dependable because you could possibly, since your interval, your x evaluations are 1 second apiece, you could somehow miss the maximum, but we did not here. That is number 6. 7. Find an approximate quadratic function model for the graph data by estimating the coordinates of the vertex and using one other point. You can use different things here, and I was very liberal in what could be used. A lot of you were kind of looking and projecting and chose this point here. Now if you'd chosen one other point like this 4, 2.5, that could be all right too, but I chose, and many of you chose this one, 4, 2 as our vertex. So that's the vertex I'm going to use here, and again many of you used others, which you got full credit for. And this one other point is on the y-intercept. I'm going to call that 0, 7.5. So now we're going to go ahead and write a function here, f of x equals a, which we don't know yet, and h is equal to 4, k is equal to 2, so we have x minus 4 squared plus k, which is 2. And now we're going to use this 0, 7.5 right here. So I'm going to put 7.5 is equal to a times 0 minus 4, 0 substituting for x, squared plus 2. And now we have, working below, we have 7.5 equals negative 4 is squared is 16, so we have 16a plus 2. And subtracting 2 from both sides of this equation, we have 16a is equal to 5.5, and dividing by 16, we have a is equal to 5.5 over 16. And you can decimalize that, isn't it? You can also simplify this by multiplying both the numerator and denominator by 2, so we can write this as, rewrite this as 11 over 32. And you can decimalize this also, which I'm going to do. So many different ways to get the correct answer on this. And if you used a different one than I did, so 0.34375, you could use that. So I'm going to write our function here, f of x is equal to, I'll put 11 over 32. We're going to have quantity x minus 4 squared plus 2. And so we're going to put this right over here. Now we're going to sketch this and see if it fits in like it should. So go to y equals 11 over 32 we come out here, quantity x minus 4. Is that what it is? Make sure I have that right. Yeah, squared plus 2. Ooh, you know something? I have messed this up, haven't I? Because that's supposed to be 5 comma 2. I'm going to change everything. So h equals 5. Let's put 5. That'll be 5 there. And then we'll just change everything here, right? And this is going to be this. This will change here. This will change here. That's going to be right, but this is going to be the same. I'm going to change. I'll change all this. If you used 4 comma 2, that would have been all right too. I mean, it would have been sort of a little bit close. Let's go ahead and change all this. So we're going to have 0 minus, we're going to have x minus 5, 5, and we're going to have 25, 25a plus 2, subtract. We're going to get 5.5 over 25, which is going to be 11 over 50. And that's going to be 0.22. Let's do this. .22, yes, that's what it is. So we go to 11 over 50 here. X minus 5 squared. Okay, this should be it. Let's do that now. Okay, we'll put 50 down here, and we'll put 5 up here, squared, plus 2. I hope this is it. I'm going to put a standard window zoom 6. And we have our vertex at 5 comma 2. We have our y-intercept at 0 comma 7.5. So let's go ahead and sketch that in. So it looks something like this. And let's see, we're going to have 5, 7.5. It should come back right here like this. And 10, 7.5. Let's see in the calculator, does that? 10, 7.5, check. Okay, all that is good. Correction in real time. You saw me do that. All right. 8. Let's make sure everything's there. Yeah, this 0, 7.5 kind of got off the screen a little bit. Yeah, 0, 7.5. Y-intercept. Okay. Next. A given parabola has a vertex at -4, 3 and another point at -2, -5. Write the parabola's quadratic function in vertex form. Again, that vertex form is going to be f of x equals a times quantity x minus h squared plus k. To me, this one's easier because you can just use the points and you don't have to figure out what is what. So our vertex is going to be -4, 3. So for this, h is equal to -4, k is equal to 3. So that's going to give us f of x is equal to a times x minus -4, which is going to be x plus 4 squared plus k, which is 3. And now we can use this other point here, -2, comma, -5. And so I'm going to put -5 is equal to a times -2 for x plus 4 squared plus 3. And so we're going to get -5 equals -2 plus 4 is 2, and 2 squared is 4a plus 3. And now solving for a, subtract 3, subtract 3. We're going to have -8 is equal to 4a. And dividing by 4, we have a is equal to -8/4 or -2. And so our function is going to be f of x is equal to -2. We have quantity x plus 4 squared plus k, which is 3. So that will be our answer. I want to make sure that is correct. Okay, good. Next, we're going to go to number 9, which is one of the more challenging problems. And the mistake I saw made in this one was not following the directions properly. What happens is we are going to find the x-intercepts and write this in what we call factored form, and then one other point. So what I'm going to do, and again, many of you wrote this in a different way, I'm going to use what one of my students did. Riley did a good job in this. He picked an x-intercept here at 0.5 and also at x equals 10. So those are the x-intercepts that Riley used, and you could have used other ones too that were slightly different. That's going to change things. So if I write these, if you did like you did 7 and 8 and estimate a point, I would have given you partial credit for this, but we really want to see the factored form here as instructed. And then also it says one other point. Well, one other point that's really prominent here is this maximum point, which occurs at, it's going to be 5,9. So that's going to be the vertex we use. So first of all, the first x-intercept is x equals 0.5, and to find the factor associated with that, if we subtract 0.5 from both sides of that equation, we get x minus 0.5 equals 0. So that's going to be one of our factors. And then also we have x is equal to 10, and subtracting 10, we have x minus 10 is equal to 0. So now we can start writing this function in factored form. We have f of x is equal to a times quantity x minus 0.5. I think Riley used 1/2 on his, and x minus 10. And so now we can take this 5, 9 and plug it in right here. So that's going to be 9 is equal to a times 5 minus 0.5 times quantity 5 minus 10. So what that's going to be is 4.5 times 5. So 9 is equal to, I'm going to go to the calculator, 4.5 times 5, 22.5. A, and so if we divide by 22.5, we get A is equal to 9 over 22.5, which is the same as 18 over 45. And if we divide that by 3, let's see, we get, I think, 6/15. And then that's going to be, is it 3, let's see what I got here, -2/5. And by the way, that's going to be negative. Somehow it's messed up here. Yeah, we're going to get -22.5. That's right. So we're going to get negative. So -2/5. So our function is going to be f of x equals -2/5, and we're going to have x minus 0.5 times quantity x minus 10. And again, if you have slightly different answers here for that because you use different x-intercepts, perfectly understandable. Going to the calculator here, we have, so I put, let's clear this out. So we have -2/5. Then we're going to have quantity x minus 0.5, and then x minus 10. Those parentheses, we should have it right here. Make sure the points are hit. We see our x-intercepts at, I'm going to change the window a little bit here. I'm going to go 0 to 10. And I'll go -1 here. It's a little tighter view here. So we have our x-intercepts here at x equals x equals 0.5 and at x equals 10. And we have this value right here, 5, 9, 5 to the right, 9 up, check. Looks like our vertex is just to the right of that. And so sketch the graph of that. Well, the sketch graph is going to look like this. So it's going to hit right here, have the maximum just to the right of that, and then go down like this. So something like that. Vertex will be right here at like x equals 5.25, I think. Anyway, that's our axis symmetry, but this is our function. And again, if you have a slightly different version, we'll definitely be looking for a negative a, but that'll be an answer to that. That's Riley's. 10. The graph of quadratic function has a vertex at 5, comma, -2 and opens downward. Can each of the following points lie on this graph? Well, my strategy for this one is to make a sketch of this vertex and then try these points to see if they work. So I put 5, -2. So if we go to the right, 2, 3, 4, 5, and down 2. So this is the value we have here. We have 5, comma, -2, and that is our location of that vertex. And we are opening downward. So let's check these other points. We have 1, -7. Well, that's 1 and down, 2, 3, 4, 5, 6, 7. So 1, -7 is going to be right here. Is it possible that this value would be included in that parabola here? Yes, it is. Okay, erase that line. There we go. Next, 3, -5. So we go 1, 2, 3, and down 1, 2, 3, 4, 5. There's 3, -5. Okay, for this vertex, can that point lie on that parabola here? Yes, it can. And so that'll be a yes also. So number 1, so A was yes, B was yes, and now we have 7, -2. Well, that's going to be to the right 7, so 6, 7, -2. So here's 7, -2, and 7, comma, -2 lies horizontal to the vertex, meaning that a downward opening parabola could not include this point 7, comma, -2. Next, 11. Write the quadratic function for a parabola that has an axis symmetry, x equals -2 points. So we have x equals -2. So here it is, x is equal to -2. Points 3, -3, comma 2, and 0, comma 11. So our axis symmetry is going to be the formula x equals h, and in this case h is equal to -2. And so our vertex form is going to be f of x equals a times quantity x minus h, which is going to be x minus -2 or x plus 2 squared plus k. So now we have 2 points to work with on this. So I'm going to take first for the first point, -3, comma 2. We're going to have 2 is equal to a, and we're going to put -3 plus 2 squared plus k. And simplifying down, -3 plus 2 is -1, and -1 squared is 1. So we're going to have 2 is equal to a plus k. Okay, next for 0, comma 11, we're going to get 11 is equal to a times times 0 minus, or 0 plus 2 squared plus k. And for this, we're going to get 11 is equal to 2 squared is 4, so 11 equals 4a plus k. And so now we have a system of equations, and what I'm going to do is take this first equation and place it right underneath. So we have 2 equals a plus k, and we are going to eliminate by subtracting that bottom equation from the first. So we have 11 minus 2, which is 9, and then we have 4a minus a, which is 3a, and then we have k minus k, which is 0. So if we divide by 3, we're going to have a is equal to 9 divided by 3, or 3. And then we can take this 3 and plug 3 back into this first equation. So we have 2 is equal to 3 plus k, and we subtract 3, we have k is equal to -1. So our function is going to be f of x is equal to 3, and we're going to have x plus 2 squared and minus 1. K is minus 1. So I'm going to write this up here. 3x plus 2 squared minus 1. So this is where our vertex is. And then we have a parabola with a equals 3, so it's going to be up 3 like this. Kind of a pretty skinny parabola. So any sketch of some people sketched look a little triangular, not getting that nice curve. I didn't take any points off for such artistic deficiencies. 12. Is each set of information enough to create a unique parabola? This problem condenses the work we've done already in problems 7, 8, and the last one, 11 even. So A, the vertex and a second non-vertex point. Well, that's what exactly 7 and 8 were, right? We had a vertex. By estimating a vertex, this case chose 5, 2, and another non-vertex point. Same thing for problem 8. So yes. Oops. Two x-intercepts. Well, remember in problem, what was it? Problem 9, we had 2 x-intercepts, but we needed to have this other point 5, 9. So that is not sufficient. The vertex and the range. Well, the vertex and the range, well, the vertex will tell you if the range will tell you if it's opening up or down, but doesn't tell anything else about the width or narrowness about A. So C is no. Finally, D, the range, the axis symmetry, and the x-intercept. Well, the x-intercept, one x-intercept, will be one other point. The range and axis symmetry would give us the vertex. So this is kind of a convoluted way of saying the vertex and then one other point. Of course, that's presuming that we don't have a minimum or maximum of y equals 0, but but generally we'd say, otherwise we'd say yes. So that's what 12 looks like. 13, the cables on either side of a pedestrian suspension bridge are in the shape of a parabola tower support. The cables are 100 feet apart and 27 feet high. The cables are at a height of 2 feet midway between the towers. What is the height of the cable point that's 20 feet from the center of the bridge? So we have here a case of 2 towers whose height is 27 feet. So I'll put 27 feet. And then these towers are 100 feet apart. And then we have cables that stretch between the 2 towers that are in the shape of a parabola, and the height of this is 2 feet off, so this is going to be 2 feet right here. And then what is the height of a cable at a point that's 20 feet from the center of the bridge? Well, you can do this different ways. One thing you can do is you can take your coordinate grid like this, your x and y intercept. But I like to do it, I think it makes it easier if we just make our y-axis right along that vertex. So we'll have x and y here. And what that does, this makes the coordinates of that vertex 0, 2. And then it brings our one other point here. We're going to have 50. And where do we get 50? Half of 100, comma 27. So this is what we can use to create our function. So we're going to have f of x is equal to a, and then we're going to have x minus h. Well, h is 0, so that's going to be x squared plus 2. And to use our one other point, we take 27 in place of f of x equals a x squared plus 2. And we subtract 2, we get 25 is equal to a, and using x we'll have 50 squared, or 50 squared times x, so we have 25 equals 2500 a. So a is going to be 2500 divided by, oh excuse me, I got that backwards. A is equal to 25 divided by 2500, which simplifies to 1/100th, which is going to be 0.01. So our function is going to be f of x equals, I'll put 0.01, we're going to have x squared plus 2, and then we can plug in 20, so f of 20 is equal to, and we can go to our calculator, and I'm going to put it right here like this, 0.01 x squared plus 2, and then see what we have. We can look at the table view. If we go to second graph, we have right here where x equals 0, we have 2. And then we go down to x equals 20, we have y equals 6. Equals 6. So our answer to the question will say 6 feet. Okay, now the last problem here, 14, we have 4 different separate problems. Determine if each function fits a parabola that opens downward and has x equals -5 as the axis of symmetry. Well, if x equals -5, we're going to have, our function is going to be the form of f of x equals a, and we don't know if the function opens up or down, but for x equals -5, we're going to have, for h equals -5, I put x equals -5, for h is equal to -5. There we go. And so we're going to have x minus -5 or x plus 5 plus k. So we have to have x plus 5 to make this work. Do we have that here for A? No, we have x minus 5. Do we have that here for B? No, we have x minus 5. Okay, but for choices for C and D, yes, we have x plus 5 and x plus 5. So that, ladies and gentlemen, is it. I hope this has been helpful to you. Good luck, and as always, thanks for viewing.